Okay, hello everyone. Today I'm really excited to talk about very exciting topic on how can AI help to reduce disaster risk. But again, maybe good to introduce myself. I am Saman Ghaffarian. I am an assistant professor or lecturer in Geospatial Data Science at Department of Risk and Disaster Reduction, University College London. So today, let's start talking about my own research about myself. So, sitting in disaster and risk reduction department, I'm actually doing disaster risk management, including damage analysis, recovery, vulnerability, and resilience assessments. So, but using with emerging technologies and the new provided tools like artificial intelligence, including explainable, responsible AI, and generative AI. Also, other two emerging technological tools like geospatial data, Earth observation, GIS, remote sensing, and all together with a new trend and new emerging topic of digital twin. But I started actually with the inspiring question of can AI reduce the risk? Of course, today I'm going to talk about how can AI reduce the risk, but my question at the start, how can AI reduce the risk or can AI reduce the risk? So today I'm just going to talk about, provide a taster lecture on this, how I actually teach this topic, and how we use AI integrated with geospatial science to address risk and disaster management topics. So to start with, I would like to show an image that I just today asked a generative AI platform to generate this image for my presentation. I'm just going to use this point to provide information about the connections between the fields that I am talking. So as you can see, that the topic is about AI, but I will then connect it how geospatial data integrated with AI can help to reduce disaster risk. So I will start with the topic of disaster risk management, and then I will connect it to AI and geospatial science to provide some information how this can be done. And these are the actual information and topics that we teach during our programs in undergraduate and postgraduate modules. So let's start with the definition of risk. You know, when the term risk pops up, everyone has some understanding. You know, something came, bad to adverse events of something in our mind. We have some perception of risk. But in disaster context, the United Nations Group on Disaster Risk Reduction actually provide a very comprehensive detailed definition for this for the risk in disaster context, and it says that the potential loss of life, injury, or destroyed or damaged assets which could occur to a system, society, or a community in a specific period of time, determined probabilistically as a function of hazard, exposure, vulnerability, and capacity. This is how we define risk. But, of course, this is a very comprehensive definition, but it provides very essential information for us in how to analyze, how to actually measure the risk. It says that this is a function of hazard. So the hazard, its intensity, its characteristics are important for us. The exposure, the elements at risk that could be exposed for this hazard are important for us. This could be building, this could be people living in the disastrous areas, and it also talk about the vulnerability and capacity. So vulnerability also related to the exposed elements at risk to that defined or certain hazard. Then the capacity, one step forward, it's mainly talking about the coping capacity of those elements at risk when exposed to that certain hazard type. So there are essential information for us how to actually measure risk and how to prepare for disaster risk and how to effectively and efficiently do disaster risk management. So starting with this one, we can look at disaster risk management based on two different situations that they are based on the time and the time of the disaster and the situations for before and after disaster. So we have pre-disaster and post-disaster, just let's say before the event happens or just after the event happens. So there are mainly two phases or components for pre-disaster. These are the main components that I'm talking about, how we can effectively do disaster risk management. This is a very general perspective on disaster risk management. So in pre-disaster situation, we could do mitigation prevention analysis, we could do preparedness. In mitigation prevention, we try to prevent upcoming or imminent disaster, or at least limit the impacts. In preparedness, again, we are just trying to prepare, the imminent disaster and upcoming disaster. So using all our capacities, individual government capacities to best prepared for the upcoming disaster. And in the post-disaster situation, because just the disaster happened and occurred, we have the response phase. And in this response phase, we try to actually do the emergency response operations, rescue operations, resource allocations, and etc. And we do have the recovery to actually recover from the impact of that disaster. So within those phases, and based on the definition that we provided for risk in the disaster context, we can have some measurements. Those assessments or measurements could help us to provide information to better disaster risk management for the decision makers actually. So we can do, for example, in pre-disaster, do the vulnerability assessment or the resilience assessment or the hazard modeling. So for example, vulnerability assessment could provide very essential information about the vulnerability of any elements at risk that could expose to the upcoming disaster. For example, the vulnerability of buildings to the upcoming earthquake. And same for the resilience assessment. Hazard modeling is another aspect that we said that this is also an important function. We should know what is the intensity and what are the characteristics of the upcoming hazard. Also, we could do the damage and impact prediction. All of these measurements and assessments could help us to mitigate or prepare for the upcoming disaster. So for after disaster, we actually we have the emergency responses just after disaster. We should do the damage and impact assessment, and this is very essential for better coordinating the response operations, to better provide the coordination for resource allocations, and also further, we can use it for planning for the recovery. Because we had an impacted area. Now, after concluding the emergency responses and operations, we would like to recover. We would like to build back the area at least to the normal condition and before disaster condition. So during the recovery, also we need to monitor the recovery because not always everything goes as planned. So we need to monitor, assess to understand if everything is actually going as planned or not. And we may need to revise the recovery plans based on these assessments and, of course, other aspects of the recovery. So as a whole, looking at this entirely, sometimes this disaster risk management and components can be seen as a cycle because, okay, let's say an earthquake happens, we did the response and recovery, and again, mitigation and preparedness, because to some extent, we are sure that another, for example, earthquake going to happen. So it can be seen also as a cycle, and we may call it, in some cases, not all the cases, as a disaster risk management cycle. So here, we know that there are some measurements, assessments that are essential for us to do efficient disaster risk management. So we know that we need those. And coming back to our first question, so now we know what we need in reducing the disaster risk. Now we will look at, after introducing the AI and geospatial data, how we can use AI to actually provide essential information for effective disaster risk management and finally to reduce the disaster risk. So let's go into AI. Artificial intelligence actually nowadays it's a fancy word and actually revolutionizing all the fields. But in principles, it's the ability of machine to perform tasks that normally require human intelligence, such as reasoning, learning, problem solving, and decision making. But we have also a branch of AI called machine learning. And when I call AI here, I mainly mean machine learning. So machine learning is the study of computer algorithms that allow computer programs to automatically improve through experience. I will also come to this, provide some more information how we could use machine learning to actually do the risk and disaster management. Also, we have deep learning, which is a subset of machine learning, and it uses neural networks to analyze different factors with a structure that is similar to the human neural systems. So just deep learning is a subset of machine learning within AI. But at the end, machine learning and deep learning methods are mainly used to process, let's say, digital data and extract insights and knowledge in an automated manner. So these are the benefits, how we can use these tools in general. So it's about processing data in an automated manner and provide insights and knowledge. So as I said, machine learning is study of algorithms that improve their performance at some task. This task can be a classification task, could be a regression task, and or could be a forecasting task with experience. Experience here mainly refers to the data that we use. And mainly within these machine learning methods, we have a performance criterion that we need to optimize it to achieve the best prediction and best model to have the best prediction based on that developed model. So in general, we have in machine learning two phases. We first develop the model, which we call it the training phase of machine learning. Within this, we have raw data, we have target or labeled labels for those data. Then we have some other analysis based on different algorithms to actually develop the model. So in the first phase, we develop the model. In the second phase, we use the developed model and integrate or implement it on the new data to do the prediction. So first, we develop the model based on training. Training means using the data and experience, provide the experience for the model to learn from them and then use the developed model to predict based on the new data. And it depends on our target. It could be impact forecasting, it could be damage assessment, it could be vulnerability assessment, and so forth within our disaster risk context. So there are mainly four machine learning types. One of them is supervised learning. The other ones are unsupervised learning, semi-supervised learning, and reinforcement learning. So very briefly, supervised learning use data points with labels. We need to have some understanding of the training data to develop the machine learning models. But in unsupervised learning, we don't care about the labels of the data. Just we try to group the similar data points in different groups or clusters. In semi-supervised is a bit in between, and we have a few labeled data, and most of them are unlabeled data. But it starts with the labeled data, then fine-tuned based on the unlabeled data. Reinforcement learning is something very different to other ones, and it has agents that based on the actions with an environment and making decisions and taking some having some results as penalty or rewards within this decision making process, they improve themselves and train the models and develop the models. So now we understood very briefly what is AI, what is machine learning, how machine learning or deep learning models could help us in general. And we said that machine learning and deep learning models are mainly to extract insights and knowledge in an automated manner by processing the digital data. So now we have disaster risk management phases and the measures that we need. Now we have AI in hand and machine learning to process digital data. Now we are going to look at the geospatial science and geospatial data as one of the sources, let's say best sources to provide the required digital data that can be processed by AI and provide essential information for those assessments to reduce the disaster risk. So, looking at in the geospatial science and data, we have three main components or just data types. One of them is geographical information systems or GIS data or layers. It's actually it provides mainly the end user products coming from different data sources. It includes also remote sensing data. There could be different GIS layers, including maps from historical data. It includes also metadata coming from socio-economic surveys and etc. Putting all together and provide some essential information, aggregated information for decision making. Also, GPS is another data for geospatial, and we all actually know what is it. And it's about providing coordinates and location information for the users. We all, I guess, that use at least GPS in our daily navigation and providing our way in our daily navigation. So remote sensing is another type of data and is the process of detecting and monitoring the physical characteristics of an area by measuring its reflected and emitted radiation at a distance, typically from remote sensing, aircraft, or drones, depending on the platforms, remote sensing platform that we are using. There are different also definitions for this. I put another one here to better understand what is remote sensing. But in general, also we have remote sensing platforms like satellites, aircrafts, drones. We have also sensors that can be assembled on those remote sensing platforms. So also the sensors themselves provides the information about the data types, the products of remote sensing. So we can also split these data types or sensors to two main types: passive sensors and active sensors. In passive sensors, actually, the sensors, remote sensing sensors like satellite sensors, just collect the radiated or reflected radiations from the objects and features, for example, from the Earth's surface that are emitted by sunlight, by sun. So we are just collecting the sunlight reflectance from the objects. But for active sensors, they actually produce their own radiation. They produce the radiation in certain wavelengths and then actually collect the reflectance from the objects for that certain radiation that they already emitted. So now we understood this, but why remote sensing is important for us in disaster risk management? Just one example here. One of them is that we can use it for to cover a wide area, a big area, larger scale area, and look at that area in certain times. For example, here we look at the multispectral satellite images for damage and recovery monitoring. Here you can see the image, an image of part of Tacloban city in the Philippines, which hit by Typhoon Haiyan in 2013 November. You can see this is just before Typhoon Haiyan hit the area. So we can see the buildings, water bodies, slum areas, vegetation, trees, and all the land covers that we can actually see them in the image. But how we can use multispectral or let's say multi-temporal data here? So if we look at the just after the disaster. I guess this is 4 or 5 days after the typhoon hit that same area. So looking at the same area and understanding, we can easily see that the extent of the damage is really big, and it's almostly washed out the slum area in the coastal region here. So it provides very quick and important information for us when just we have a look at this and we can understand some extent of the damage. Just imagine that if we could provide the entire the satellite image for the entire area, it could provide much more information for us. This is just an example. So if we also continue looking at the same area in different years, for example, if you look at in the image almost after 3 years, we can see that most of the buildings are rebuilt and reconstructed. So we can have also some understanding of the recovery area. So this type of information can be provided by remote sensing, in particular here, satellite images. But this is just visual. We can just visually look at them. If we want to analyze them and, for example, provide some statistical information, we need to manually count them. Okay, there are 100 buildings here. Now looking at the after disaster, almost 70 buildings are damaged. Now looking at the recovery, I need to manually count the reconstructed buildings and etc. All this process, if we need to do that manually, takes time, and it's a cumbersome process, and it may have certain uncertainties and inaccuracies. So coming back to our main aim, which is how can AI help to reduce disaster risk? We understood again how geospatial data can help us, can provide the information, or not exactly information, the data, digital data we need. So now we are going to have see some examples how AI can process geospatial data to provide information for disaster risk management and answer the question of how can AI help to reduce disaster risks. So this is actually, we said that geospatial data is for providing data. AI, as I mentioned, if we don't have AI, we need to process those data manually, and it takes time. So, but AI here is to automatically, accurately, rapidly analyze, process those data, and provide essential information for disaster risk management and all the assessments that we require in disaster risk management. Now I will just focus on some damage and recovery assessment examples here, just for the case of this taster. Again, looking at the same area, in the left side, we can see the Philippines map with the Typhoon Haiyan again, with the path of Typhoon Haiyan in red line. In the middle, you can see the very high resolution satellite image captured for Tacloban city. This is only for the Tacloban city. And in the right side, you can see the generated land cover map for pre-disaster. So here we have satellite images. Say that we have satellite images and we want to do the land cover map. To do so manually, we need to one by one look at the buildings, look at the areas, and draw the polygons to do the land cover map. But with help of AI, we can easily do that very quickly and rapidly. So the land cover map actually has been produced by implementing machine learning and processing those satellite images based on machine learning algorithm. So how we can use this actually in the right side with the pie chart, you can see that it provides the overall land coverages for that area, and we can have some understanding for pre-disaster. So if we continue and look at this in damage and look at the damaged satellite images and just, for example, 4 years, we can understand the extent of the damage and recovery. But before going to that example showing that damage and the recovery, here, for example, is how we can use machine learning algorithms, in particular support vector machine here, looking at the different time-lapse satellite images and processing automatically the satellite images and providing the land cover maps, and then we can have land cover based damage map and recovery. For example, for the same area, you already saw the pre-disaster land cover map on the top. But when we go for the damage, and here you can see the satellite images in the left middle side, the satellite images just 3 days after the disaster. And next to that, you can see the land cover map, including the damaged area. And it provides the essential information in the extent of the damage. If we continue and capture the images, for example, here for 4 years after the disaster, after the typhoon case here, we can now understand what are the recovery rate here. Just compare the after 4 years after the disaster with the pre-disaster situation. You can understand if the area has been built back to the before disaster situation or not. There are also other examples for this. We can use machine learning models for large scale damage and recovery monitoring. Of course, then we need more remote sensing data, and then they become big data types and big data for us. In this study also, we look at the entire Leyte Island rather than only looking at the small area here that it is Tacloban city. We can look at the entire Leyte Island and use the enormous or really big remote sensing data that here you can see that there are more than 400 images that has been used here for analyzing the remote sensing data, and we use the machine learning algorithms, and here specifically we use random forest to produce the land cover maps, and finally based on the land cover maps that are produced for different time lapse and doing the change detection, we can produce the damage and recovery maps. And all this has been done on a cloud computing platform, namely Google Earth Engine. It means that we only used one web browser, just a web browser, and did all this analysis. This web platform or the cloud computing platform named Google Earth Engine provide all the data and the functions to implement the machine learning algorithms. And you can see based on the large scale damage and recovery maps, we can provide essential information for, you can see here on the red colored map, for the damage ratio. These are the municipality boundaries, and we have some understanding of the damage to the damage level to the different municipalities. And then again, looking at the 3 months after the disaster, 1 year and 4 years. So after 4 years, we can see that almost completely all the municipalities have been recovered. But you can see that these are very essential information for governments, for decision making, and we could do this just in some minutes by implementing and doing this analysis. And because of having AI and remote sensing data. Without AI, we cannot actually assess this. It takes long time to do these assessments for that large scale area. Or even we can look at it in very high resolution images and provide some more details regarding the damage and recovery. For example, here, if we have higher resolution images, in the left side, you can see the pre-disaster images. And in the right upper side, the image for 3 days after the disaster, and the right bottom side, you can see that 4 years after the disaster. So just visually, we can see again the extent of the damage almost. But again, to do that in a for the large scale areas, for several images and buildings like this, we need AI to do that in an automated manner. So we can see that there is a damage to buildings, even in the recovery phase, in the reconstruction. We can see that even it has not been being built to the pre-disaster situation condition, but they has actually extended the building. So these are very essential information for decision makers, and those information can help us to understand the area better, and finally, or let's say indirectly, help the governments and help us to reduce the risk. Here, for example, we use the deep learning model. I'm not going in deep of these details, but just to understand that we use a deep learning model to analyze different integration of different geospatial data types, including GIS and satellite images, and finally, automatically update the building database for damage assessments or recovery monitoring. Here you can see some examples of the results. In the left side is the pre-disaster image. And next to that, we have just after disaster image in the upper example. And the binary image is the actual ground truth, and the right one is the result of the deep learning model. That it shows very good and promising results in terms of automatically updating the building database from high resolution satellite images. So also we can look at the recovery phase and see if the buildings have been reconstructed or what is the extent of the recovery. And if we need to revise the recovery plan, if everything goes as planned or not. So AI could help us to analyze automatically and processing the satellite images to understand the extent of the recovery and further provide insights and knowledge for decision makers. There are some more examples, and again in the left side are the pre-disaster images. And next to that, we have just after disaster, 3 days after disaster satellite images. We have a ground truth that this is the desired outcome. And the results here that here the green areas shows successful detection of the buildings. And we have the red areas, false positives, and blue as the false negatives. The blue is actually the false negatives are the buildings that has not been detected by the model. So again, conclusion, as the conclusion point, of course, AI can help to reduce the disaster risk because it can provide information by processing the digital data, including geospatial data, which provide essential information for us for a widespread area, and help us to effectively do the risk and disaster reduction, and finally help us to manage it in an efficient and effective manner. So this is actually is the end of my test lecture here. I'm happy to answer your question if you have any.